For the bisection search, one of the key is you need to have a low bound and high bound. But since this is the finding out the minimal payment, I guess the minimal payment is the lower bound should be zero. It can be negative. Then you will be taking money out again, right? So zero is probably as low as possible. What's the high bound? The high bound, I guess, will be the balance plus the interest rate times one plus interest rate. That could basically you pay everything in one payment. That would be as high as that goes. So, and then we want to find a minimal. So let's first look for the definition is bisection search. So we look for the middle ground, and first start with the middle, and that would be. And again, we have the balance of 5,000, annual interest rate of 0.18. That way for easy grading. So, okay, so that's the starting point. For my implementation, I decided to give a total count. If I take more than 50 steps, it's probably something is not right empirically. So, and this is just my way to avoid the infinite loop. So, and then because I'm going to every time I'm going to change the balance, so I assign the global balance to a local one. That way, every time I don't have to override the global variable. So there's a new balance. Start with the 5,000, and the payment basically is there. And again, we picked just the integer, not I forgot the question. Did the question go to us as 1 penny or something? In this case, I'm going to just go to the $1. So yeah. So and then for this current payment, with that balance in 12 months, what's the balance will become? And we just new balance minus the payment and the plus new balance times the monthly interest rate. So after that, maybe I explain something here. For estimate the remaining balance after 12 months. 12 months. Is that plural? Okay, so and this is just print out some debugging information with the low bound, high bound, current payment, and what's the remaining payment. Right? So this is just for me to debug the code. If my minimal payment is too high, the new balance should be negative. That means I'm overpaying, right? So if it's negative, I paid too high. If my payment is too high, I should go lower, and that means I need to lower my monthly payment. How do I do that? I just change the high bound to my payment. I basically reduce my high boundary. Right. So if my new balance is positive, that means I have not paid off. Because this here in this example, we are just looking at the dollar one. So if it's positive, that means I paid too low. That means I need to lower increase my monthly payment. That means I need to move the low boundary to high. So the remaining balance is too high. My current payment is too low, and then I need to go high, which is move the low boundary to the current payment, and then that means the next time take the average is going to move up. So, but how do I stop this? Apparently, my criteria is actually basically, if the new balance is the less than $1, but greater than zero, like the 0.99 cents, that's good enough. Or in all the low boundary and high boundary is less than $1. Basically, I cannot move anymore. If the low bound is $9, high bound is $10, there's no room to move anymore because I'm only looking for a exact dollar amount of payment, right? So basically, that's the condition I will start. So ABS is just the absolute difference. Let's say that the high bound should always be greater than low, otherwise something would be wrong again. But let's say in this case, I just calculate the ABS, absolute difference of the high, high and low. So let's see. That actually is unnecessary because the payment is integer, but I'm going to leave it there. Let's see the running result. So I start with 0, high is 590. Apparently that's the one payment. And the current payment will be half of that. If we start that, obviously that's too high, so we have a negative balance. That means I overpaid. That means I need to reduce my current payment. Very good. That means I high bound should be lower. So I move my high bound to the current payment, which is 2950. That's very good. It's actually correct. So I moved my high bound lower, and then my current payment will be half of that with 1475. And then I still get the negative one. That means I still overpaying that. And that means I still have to move my high bound again. I move my high boundary lower, payment is still negative, and then I move it lower again. This time, 75. This time the current payment is 368, but with 368, I have a balance of 1100 something. That means now I'm endopaying, so I need to move higher again. That means now instead of moving the high boundary, I need to move my low boundary. Very good. So it looks like I did move the low boundary. The low boundary now is high. And then the payment 552. Oh, now I got the negative balance again. So I'm overpaying again. So, and then I'm going to move the high boundary. So 552 is my new high boundary. And then this time I got a negative 110 balance, and that's still negative. I'm still overpaying, so my high boundary had to be lowered again. So, and this time when I do that, well, now I got a positive balance. That means now I endopay, so I need to move my low boundary again. So now I move my low boundary high. And my low boundary is 414, previously 368. So now the average of that is probably this, 437. Now I again have a positive. Positive again, that means I'm endopaying. So I need to move my low boundary higher again. So again, low boundary 437, which is my previous payment. So move that higher. Well, it's still still have about $48 remaining. That's still too high. So I then that means I'm still endopaying. I need to move the low bound again. Low boundary now high again. Well, then it's negative. So it's basically back and forth until I narrow it down to. Finally, narrow it down to $8. $8 actually now is actually the lowest possible because there are 12 months, and 8 divided by 12 is actually less than $1. So that's actually as precise I go for the dollar unit. So I got finally got the lowest payment of 451 as the dollar unit. So, okay.
And if you wanted to get that perfect, you'd have to make it like pennies, right?
For the did the yeah, the question, did the question ask you for go for the penny?
I don't know. I can double check, but I'm just asking in general.
Yeah, in general, yeah. Let me read the question again. For by oh, it does say in other words, the amount is a multiple 0.01. Yeah, actually, it does not look at the question actually go to 0.01. So if that's the case, I don't have to do the integer. I just floating point. Oh, then that also not so absolute. Is not $1 either. I guess. That's okay. What 0.5? 0.01. Oops, where did I type that? 0.01. Well, that's good enough. Okay. What other things I need to change? Just to make it I'm going to make this float. Let's make sure that's the case. How about that? Any other things I should change? Oh, then maybe 50 is not good enough. 100? Okay, let's see. $550. Okay, it's not moving anymore. It's actually 50 remaining 0.63. Okay, it's not accurate enough. I need to oh, I know, because there is the rounding errors. So you have floating point, and then because it goes to the 1 penny, so we have that rounding error. This is actually basically a counting. I need to change this as a boundary too. 0.01. Okay. 0.01 again. Okay, let's see. Let's hope. What are the boundary I should change? Oh, is that correct? This seems to be correct now. 51. Okay, yeah. It does look like, yeah. Well, at least it seems to be correct now. So I don't see any other boundary I should change. Okay, is that correct answer? 51.63. I don't remember. Yeah, but you can double check. Yeah. So. Okay, so this is actually a good ending of the today's class. So yeah.